Have you ever wondered how a simple cloud of dust can transform into a blazing star? Today we're setting our sights on the birth of a star, an event that's as awe-inspiring as it is complex. Our journey begins in the vast expanses of space, where clouds of dust and gas, known as nebulae, drift aimlessly. These nebulae aren't just aimless wanderers, though. They're the very cradles of stars. Gravity, the cosmic puppeteer, begins to weave its magic, pulling these particles together into a dense core. As dust and gas continue to collapse under gravity's relentless pull, the core heats up and a protostar starts to form. This protostar is in its infancy, a baby star, if you will, still gathering mass from the surrounding nebula. This is the genesis of a star, an elegant ballet of cosmic forces that transforms nebulae into blazing orbs of light. So a protostar, our baby star, is born out of dust and gas, a process that might seem simple but is quite complex. So we have a protostar, but how does it grow into a full-fledged star? Well, it's all about a delicate balancing act, really. You see, as the protostar continues to gather mass from the surrounding cloud of dust and gas, its core becomes increasingly dense. This rise in density cranks up the pressure and temperature at the heart of the protostar. Imagine a pressure cooker, but on a cosmic scale. The ingredients are simple: hydrogen and helium, the most abundant elements in the universe. As the pressure intensifies, the core temperature escalates to a searing 10 million degrees. Yes, you heard that right, 10 million degrees. It's at this lofty temperature that a remarkable transformation occurs: nuclear fusion. Nuclear fusion is like the universe's own power plant. Hydrogen atoms under the immense pressure and heat start to collide and merge, forming helium. This process releases an extraordinary amount of energy, causing the protostar to shine brightly. It's this shining that we observe as the light from stars billions of miles away, but the story doesn't end here. As the protostar continues to shine, it begins to stabilize. You see, stars are a bit like the Goldilocks of the universe. They need conditions to be just right. So the inward pull of gravity, which has been condensing the protostar, must be balanced by the outward pressure created by the fusion reactions. This equilibrium allows the protostar to resist further gravitational collapse. Once this balance is achieved, the protostar graduates to become a main sequence star. The main sequence phase is the longest stage in a star's life, and it's during this time, as it steadily fuses hydrogen into helium, that the star truly shines. From a mere cloud of dust and gas to a glowing orb of nuclear fusion, the transformation is truly astounding. It's a testament to the awe-inspiring and magnificent processes that take place in the vast expanses of our universe. And voila, our protostar has now matured into a main sequence star, radiant and fiery. But what happens after the star reaches its prime? Does it shine forever? Well, not quite. The lifespan of a star is largely dependent on its mass. Bigger stars, like the brilliant blue giants, burn brighter and faster, exhausting their nuclear fuel in just a few million years. On the other hand, smaller stars, like our Sun, shine steadily for billions of years. As the stars age, they eventually burn out. This isn't a quiet fade-out, though. Instead, these celestial bodies go out with a bang in a supernova explosion that outshines an entire galaxy. What remains of the star depends on its mass. Stars like our Sun leave behind a white dwarf, a dense, hot core that cools over billions of years. Stars much larger than the Sun collapse under their own gravity to form a neutron star or even a black hole, the densest objects in the universe. Just like all things in the universe, stars too have a beginning and an end. Their birth is a spectacle, and their death is nothing short of a cosmic drama.